which is 3 squared over 2. So x equals to 50 minus 5 multiplied by 9 divided by 2, 27.5. Positive. It means that it finished here somewhere, 27.5. What does it mean? It means that this object did that way and then that way and it stopped here, 27 meters from the beginning point. Okay, now that it did stop, sorry, the velocity here was 15 in this direction. The minus is only good for the equations. When I want to show the direction, I show it with arrow. It's 15 that direction. I don't write minus 15, I just put the absolute value with the direction. Now that I know everything, I want to know everything with the graphs. So let's start with v over time. Now I leave place here for minus negative velocity. Crucial velocity times were 0 obviously. How many seconds the first part? 5 seconds here, and plus 3 seconds, it becomes to 8 seconds. Again, I had 5 seconds in the first part, 3 seconds in the second part, so 5 plus 3 is 8. The velocity was 20, then it became 0, then it became minus something, minus 15. Okay, let's see how it goes. It started here with time 0, it was with 20. When time was 5 seconds, the velocity was 0, and it's like that. Straight line because the slope is constant. Now, after 8 seconds, the velocity was minus 15. I just want to make it more proportional. Let's put the minus 15 here, so it will be like that. Okay, it's not straight line, it's this. Maybe I'll put it a little, the 5 here, so you can see a little better. Like this and like that. Okay. No, it's not good. It was 5. Just a minute, I'll do it again. Okay, obviously if you have squares and the ruler, it will be more accurate. So 20, 5, 8, minus 15, maybe like that. And something is wrong. Okay, no, okay. Minus 15. It's more, okay, now it's better. Okay. 20. Okay. Now we will see why I did it like that. Okay. First of all, this is the first part, this is the second part. Let's calculate the slope in the first part and in the second part. Both will be with negative sign, minus, because they are both lines that go this way. If I want to find the slope of the first part, vertical over horizontal, 20 over 5, which is minus 4, exactly. Here I have this triangle, or that triangle, it doesn't matter which triangle, just use a triangle. Vertically, everything in absolute value, 15 over 3, 15 over 3. Vertical is 15, 3 is horizontal, and minus because it goes down, minus 5. So now you see why I a little adjusted it. This slope is a little less steep than this one. This is much steep, it's steeper. So this will be a little less steep, this is more steep. So this is why I adjusted the graph a little bit. Now let's put calculate the areas. The first area, surface 1, area 1, doesn't matter what letter you use, is triangle. Triangle is base times height, base times altitude, height, doesn't matter, divided by 2. So it's 5 multiplied by 20 over 2, which is 50. Which is 20. What happens to me? It's 50. It's okay, 50. It means that the vehicle went in the positive direction 50 meters, exactly what happened. Now, the second part is also triangle. which is 3 multiplied by 15. Everything absolute value, we understand which way it goes according to the area. If it's under the t-axis, it goes back. Okay, so 3 multiplied by 15 over 2 is 45 divided by 2, 22.5 meters, which is backwards. So it went 50 meters that way, went back 25 meters that way, so exactly it will finish at 27.5. If you cut from 50 to 27.5, it's exactly 22.5. So it's okay. Our second graph is x over time versus time. Again, we had the 5, the 8, 0, 50, and x is position. The position is 27.5. So let's see. When time was 0, it was here. When time was 5, it was 50. When time was 8, it was there. So what will happen to this graph? In the first part, we had slope that decreases. So it will be like that. The initial slope was 20, 19, 18, until 0 when it stopped. So the graph will be like that. Like that. The slope here is 20, 19, 18, and etc. This one will also be like that, and now you will see why. The slope here is 0, then it's minus 1, minus 2, minus 3, minus 4, minus 5. We know that it accelerates that way, but the velocity is negative numbers, so the slopes is still negative. It means that it's, if you see the numbers, why the acceleration is minus? We know it accelerates, but with numbers, when we use the minus 5, it means that the velocity still decreases. Why it's okay? Because with numbers, with the number we see, the velocity started at 0, then it's minus 5, minus 10. In numbers, it's okay because the numbers decreases. Logically, we know that it increases in the opposite side, in the opposite direction. But mathematically, it's okay. And again, here we see the slope, the numbers decreases. The slope is 0, minus 1, minus 2, minus 3, minus 4, minus 5, until it reaches minus 15. The slope here must be minus 15. If you want to calculate slopes in this kind of graph, you use the derivative. The derivative, we'll show it later in one or two places, just to see how it, if you know this kind of maths. Okay, the last graph is A versus T, 5, 8. We had two acceleration. We had minus 4 and minus 5. Minus 4 was the first part, minus 5 was the second part. So everything is negative here. If I calculate the area here, it will be 20. If I calculate the area here, it will be 3 multiplied by 5 is 15. What does it mean, these negative areas under the t-axis? It means that the velocity decreases by 35. Let's see if it's okay. It started with 20, it finishes with minus 15, so the velocity decreases by 35, which is 20 plus 15, so it's okay also. Let's add the average velocity, so you'll see what it means. The average velocity, according to our definition, is the displacement over time. The displacement here is not 50 plus 22.5, it's 27.5. I remind you, the displacement is the distance between the first position and the last position. So it started here, finished there. It doesn't matter that it did this way. The distance obviously is longer, but the displacement is 27.5 and the time was altogether 8 seconds. So if I do 27.5 divided by 8, I get something 3.4375 meters per second. What does it mean, this number, this average? It means that if this object were to go in a constant velocity, this constant velocity, it would reach the same place at the same time, and it, instead of going that and that way, if it will go in this velocity at 8 seconds, it will reach exactly the same place. If I want to see it in graph, it means that if I 3.4375, if I were to draw constant line, constant velocity, if I calculate this area, I'll get exactly 8 multiplied by 3 point da 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 means 27.5. So it means that if I were to go with this velocity 8 seconds, I would reach the same place at the same time without going that way and that way back. Okay, so now we went over everything and we'll do more, even more. Okay, now let's take an exercise. Instead of giving you the data like we used to in the former exercises, I will give you a graph, and from the graph I want to understand everything. So let's say the graph is v versus time, which is the most common graph, and let's do like that. That. Okay, let's say this is 20, this is 5, this is 7, this is 10, this is 12, this is minus 15, that's it. And I want to know everything. Now there are two ways to deal with this graph. I can also, I'll write all these, again, all the 6 and like we did before, but and calculate from the formulas. But when I have graph, we don't really do it because it's easier to do it from the graph. Let's see what the story of this vehicle. Let's say this is our positive direction. What does this vehicle do? 5 seconds, let's say it started here. 5 seconds it went in constant velocity, so it reached there. 5 seconds. It reached there. This is part 1. Then the velocity still is positive, but it decreases. In 2 seconds, and the velocity is 0. So again, it comes this way in 2 seconds, and it stops. What happened then? Let's write 5 sec, 2 more sec, and it stopped. Then it changes direction. Let's see, the velocity becomes negative. Negative means that it comes back. Look at the slope, we did it earlier. The slope is this way, so the slope is negative, but what we understand that it accelerates in the opposite direction. So it starts going that way, let's say to this place, and this is part 2, this is part 3, 3 seconds, from 7 to 10. Now this is new, look at this. The velocity is still negative, so it means it's still going that way, but the graph, the line is this way, so the acceleration is positive, but it's not positive like we used to know, it's something else. It means, look at the numbers, it means, look at the number, it becomes from minus 15, minus 10, minus 9 until 0, so it stops eventually. So what does it mean, this kind of acceleration? It means that it slows down in the opposite direction. To slow down in the opposite direction means acceleration. So it's still going that way, 2 seconds, and it stops. So now we see the whole picture. When A is minus, it means one of two things. Or a velocity decreases, when A is negative, minus, it means one of two things. Or slowing down in the positive direction, or accelerating in the opposite direction. Let's do a little drawing. So maybe write it, okay. It means slow down in positive direction, or it means acceleration in negative direction. When A is positive, it also means two things, one of two things, or acceleration in positive direction, or, and this is what we have here, slowing down in negative direction. Okay, so now we see the whole picture. So when we say the acceleration is positive, it doesn't mean that it accelerates like we used to, it increases the speed like we used to. No, it means maybe it increases the speed and go faster, maybe it decreases the speed, goes slowing down, but in the opposite direction. And again with the A minus. So this is the story of this vehicle. Now I want to know everything. First of all, I know a few things. I know the constant speed. I know from here it slows down. The initial velocity is 20, the final velocity is 0, and it takes it 2 seconds. If I want, I can calculate with the formulas the acceleration. I can calculate with the formulas the final position, the first position, but we can do it just with the slopes and the areas. So if I want the slope in the slope in the first part is 0. It means constant velocity, which we know. A in the second part obviously is minus because the line goes this way, and we say vertical over horizontal, 20 over 2, which is minus 2. If I take the third part, this is the fourth part. If I take the third part, again it will be minus, but the meaning is increasing speed in the opposite direction. I see the triangle here, so it's vertical over horizontal, 15 over 3, which is minus 5. Yes, 15. What did I write here? Minus 10 here. Sorry, minus 10. Minus 5. And A in the fourth, its acceleration, obviously it will be positive, plus, because it's that way, but the plus means decreasing speed, slowing down in the opposite direction. So if we do vertical over horizontal, it's 15 over 2. 15 over 2, it's 7.5. We have all the accelerations. Now I want the displacement, the position, I want everything. So if I take the positive area, it's a trapezoid, this one. Sum of bases is 7 plus 5. 7 plus 5 divided by 2 multiplied by the height, which is 20. So it will be 12, it's 120 meters. And this is the positive area. The negative area, it's a triangle. I can calculate it with one calculation. 7 to 12, it's 5. Multiplied by the height, it's 15. Divided by 2. It's 70. Okay, 5 multiplied 15 divided by 2. It's 37.5 meters. Which means that this vehicle went this way 120 meters. Came back 37.5 meters. So if the position here was 0, the position here will be 120 minus 37.5, 82.5, which means the displacement is 82.5. The distance will be obviously 120 plus 37.5. Now, if I wanted to calculate, for example, what happened here after 9 seconds, I want to know the velocity. Let's say I want that. What I advise you to do is use the equations for this part. How do I do it? I write only for this part, I write our 6 variables. For this part, x0 is, we calculated, is 120. Because it means that it's here, it's already here, it went the 120. So x0 is 120, v0 is obviously 0, v final, I don't know, but it's less than minus 15. Time is 2 seconds, from 7 to 9, so it's 2 seconds. And the acceleration of this part we know, we calculated it. It's the third part, it's minus 5. So I have 3 from this 5, I told you this one we choose. I can calculate everything. So if we use, for example, this formula, so I'll get v final equals to 0 minus 5 times 2, which is minus 10. It's okay, it's minus 10, it's logical because it's less than, it's more number, okay, it's higher than minus 15. And if I want the x, 2 ways. I can use, so I said minus 10, and if I want the x, I can calculate it, for example, from this equation. So x, the position will be 120, the initial position, plus v0 is 0, v final is minus 10, over 2, multiplied by time, which is 2. So it's 120 minus, I don't need a calculator for that. So it's 110. So the position here is 110. So it went 120, came back 10, so the position is 110. If I wanted to calculate it with areas, this is 120, I already know. This is a triangle, now I can calculate it because I know it's minus 10. So the area will be 2 multiplied by 10 divided by 2. 2 multiplied by 10 divided by 2, which is 10. 10. So it went 120, came back 10, so the position will be 110. So if you want dots or points in the graph which are not the extreme points in the middle somewhere, take the area you want to use, write the 6 variables and just use the equations, okay? Okay. Okay, let's go a little. Now we go to our final, just a minute, kind of questions. Not colliding, but 2 vehicles. So, just a minute, I did everything with you? Yes, I did. Okay. So let's do now this exercise. Let's say I have a vehicle here. I'll put numbers in order to be good numbers. Okay, let's start. V0 is 0 and it accelerates this direction with acceleration of 2. Let's say this is x equals 0. Another vehicle start here at a place, sorry, it was 5. Another vehicle start here at a distance 21 meters with initial velocity 4 in this direction, and it also accelerates with the acceleration of 3 in this direction. This is the problem. Just a minute, I'll write it a little higher. V0 equals 0. Okay. So let's see what we have here. Let's say this is A, this is B. Car A start from 0, accelerate this direction with acceleration of 5. Car B, it starts here from velocity 4. Obviously it came from, I don't know how it became 4, it doesn't matter, but when I started my stopwatch, it was here in 21 meters ahead of this one, and it accelerates only by 3. So if this one accelerates more than that one, obviously it will overtake it somewhere. Let's say they will meet. Meeting place is here. And I want to know everything. I want to know what time they will meet, how much time it took them to meet, and of course I want to know the position. Now, how do I deal with these kind of problems? Again, I do the 6 variables for each of them. X, t, a, v initial, v final. Again, from this one. V final, I'll write vt, okay? You can write v final also, it's okay. Okay, let's write everything we know about the first one. X0 is 0. X final I don't know because I don't know where they're going to meet. T final, I don't have a clue. A is 5 because the positive direction is obviously this way and it accelerates. Okay. V initial is 0. It starts from rest mode. V final I don't know. So I only have 2 from the 5. I can't calculate nothing. I can calculate nothing. Okay, here. X0 is 21 obviously. X final I don't know, but I know it's the same X as this one because they meet in the same position. Time I don't know. Acceleration is 3. V initial is 4. V final I don't know. So now I have a problem. What's my problem? I don't have enough data here or there to use our equations. In this case, what we do, we define a variable and use it with in the equations. We define t as t. We write time is t. So time here will also be t. Why? Because the time that it comes from here to there, it's exactly the same time from here to here. Now let's find the x with the function of t and the x with the function of t here. We'll use this equation. T plus a t squared divided by 2. So for car A, if I use it, I'll write x equals to 0 plus 5 t squared over 2. For car B, if I use this equation, I will get x0 is 21 plus 4t plus 3t squared over 2. So I have the position of each car is a function of t. If I know the t, I can place the t, find the position. Place another t, find another position. I want to find the t that makes the position will be the same, that it will be, that they will meet. So what I do, okay, obviously, I compare them. So I do 5 t squared over 2. I want to know when they will be in the same position, the same x. So 21 plus 4t plus 3t squared over 2. Okay, let's calculate it. When I move everything to this side, I'll get 2.5 minus 1.5 is 2 squared, minus 4t minus 21 equals 0. It's t minus 7, t plus 3 equals to 0. So t equals to 7 or t equals to minus 3. Negative time not in our school. So after 7 seconds they will meet. I want to know where they will meet. I just place as x equals to 5. It doesn't matter which formula you use because it's the same x. 5, 7 squared over 2. I'll use my calculator. 5 multiply 7 squared divided by 2. It's 122.5 meters. Now I know almost everything. I know that they will meet at 122.5. 122.5. T is 7. I also want to know the velocity of both of them. So let's use v final, vt equal to v0 plus v plus a multiplied by t for each of them. For car A, vt will be equal to v0 is 0, a is 5, t is 7, it will be 35. And for car B, we'll get vt equals to v0 is 4 plus acceleration is 3 multiplied by 7, 21, 25. So it's 25, 35. Now, let's see how we get information from the graphs. Let's do graph v over t for both of the cars. The time, obviously the critical time here is 7 and 0. The velocity, it starts from 0, the A car, and finishes in 35. The other car started in 4 and finishes with 25. So let's start with car A. When time was 0, it was 0 velocity. When time was 7, it was 35. Obviously it will be a straight line because the slope is the acceleration and the acceleration is positive and constant. The other vehicle started with 4 and finished with 25. So this will be the graph. This is A, this is B. Let's see if it's okay. If I calculate the slope of, let's say this is A, the black, I'll get 35 divided by 7. 35 divided by 7, it's 5. The acceleration is 5. And if I do the red, if I use a triangle, this triangle, I'll get 25 minus 4, it's 21 divided by 7. 21 divided by 7, it's 3. The acceleration is 3. If I calculate areas, if I calculate this big triangle area, let's say S1, SA, it will be 7 multiplied by 35 divided by 2. And if I have SB, the trapezoid, sum of bases is 4 plus 25 divided by 2 multiplied by the height is 7. Let's see what I get. I get 7 multiplied by 35 divided by 2 is 122.5, which is exactly what happened. It did all the 122.5. This one was 4 plus 25 divided by 2 multiplied by 7, 101.5. Why is it okay? Because this car did only 101.5 because it was 21 meters ahead. If you add the 21, you will get exactly the 122. Okay. This point is very interesting point. It means the velocity of these both vehicles are the same. But what it really means, if we go a little further, up until this point, the velocity of the B car was faster, and from this point, A car is faster, which means that when we reach this point, from this point, the A car started decreasing the distance between the two vehicles. Up to this point, B goes faster than A, so the distance between A and B grows. And from this point, A starts moving faster, the distance between them starts decreasing. So this point tells us the biggest distance that can be between these two. If we want to calculate it, it's a very interesting point, we need to know the graph of the equations of these two graphs. How can we find the equations of these two graphs? This equation is exactly the equation of these two graphs. For A, but we leave the t and the vt open, so it means vt equals to for graph A 0 plus the acceleration of A is 5t. So this graph is v equals to 5t. This graph, exactly the same equation, will be vt equals to v0, which is 4, plus the A is 3, plus t. So this graph is v equals to 4 plus 3t. If we compare them, we will ask ourselves when the velocity is the same. So if we do 5t equals to 4 plus 3t, we'll get 2t equals to 4, t equals to 2. So after 2 seconds, just a minute, let's see if it's okay. After 2 seconds, I can find the velocity. after 2 seconds, the velocity from will be 10. It doesn't matter which equation you use, because if you put 2 here, 6 and 4 is 10, 2 multiplied by 5 is 10. So after 2 seconds, the distance between these two vehicles is the maximum. If we want to find this distance, we can use areas. The area of this triangle is SA, let's call it. It's 2 multiplied by 10 divided by 2, it's triangle this, multiplied by that, over 2 is 10. SB is trapezoid, it's this trapezoid, which is sum of bases, which is 4 plus 10 divided by 2 multiplied by the height, which is 2, which is 14. So what does it mean? It means that after 2 seconds, vehicle A went 10 meters here, it came here, and vehicle B went 14 meters from the 21, which is 35. 14 from here is 35. So the distance between the car is from 10 to 35 is 25 meters. And this is the maximum range. After this point, A will be faster, so the range will be decreased until they meet. Very interesting point, this point. Okay. I want to show you another thing. I want to show you the x versus time. So I'm wiping this one off. If I do the graph x versus time, again 7, critical position were 21 and 1 to 2.5. A vehicle started here and finished there. It can't be straight line because again the velocity increases, so the slopes go steeper and steeper. It must be like that, graph A. Slope is 0 because it started with 0 velocity and it finished with 35 velocity. Graph B also started with 4 velocity and also increases. So it's also like that, something like that. But the slopes is, it starts with a slope of 4. It's not flat, it's slope of 4, 5, 6, 7, 8 until the slope will be 25. Now I can show you, if you know a little higher maths, you can see something very nice. The equation for this is A, this is B. The equation for this part is exactly that. X function of t. It's x equals to 2.5 t squared. If you derive it, if you do the derivative, you will get 5t if you know this math. And what does it mean? We said that the derivative is the slope, and the slope is the velocity. So it's exactly the velocity. I wiped it off earlier, but see, it's exactly the same equation that we had for the velocity. And if I place t0, I'll get the velocity here, which is 0. If I place 7, I'll get 35, and the velocity here is 35. Let's see it here. The equation for this graph is exactly this one. X equal to 21 plus 4t plus 1.5 t squared. This one. This one. It's x function of t. If I derive this one, I'll get the derivative 0 plus 4 plus 3t, which is exactly the velocity versus time for, here, you can see it here, exactly the same, exactly the same. And if I place 0 from here, I'll get 4, and the slope is 4. If I place 7, I'll get 25, so the slope here is 25. If you know this kind of math, it's nice to see how everything adds up. Okay, one more. Okay, we are almost done. I almost showed you everything. Let's do 2 vehicles opposite direction. Again, I'll take something from here because I want good numbers. Okay, Let's say this vehicle starts with 0, but accelerates with the acceleration of 4 in this direction. Another vehicle starts from here. This is x0, this is x560, and it moves with constant velocity of 12 meters per second. Never mind the units. Obviously they will meet. This vehicle, let's say this is A, this is B. Vehicle A starts with velocity 0 and start accelerating in this direction. This one, B vehicle, goes in this direction in a constant speed. Obviously they will meet somewhere here. I don't know where. Here, it doesn't matter. I want to know exactly where and when. And let's say they come and they simultaneously go from when this one is here, this one is there, and okay. Let's say this is the positive direction. So again, I'll do A, let's put B here, B and A. B is constant speed, so I only do 4 variables. A is accelerating, so I do all the 6. Okay, let's put our data. B started with 560. I don't know where they're going to meet. The velocity is not 12, it's minus 12 because it's opposite our positive direction. Time, I don't know when it's going to meet him. It started 0, I don't know where it's going to meet him. V0 is 0, V final I don't know. Acceleration is plus 4 because it's in the positive direction. Don't know. So what I do, again, I place T here, and I use this T in my equations. The equation for B is only 1 because it's constant speed, it only can be this one. I use this equation. So I'll get x equals to 560 minus 12t. A, I'll use this one. So I'll get A equals to 0 plus 4t squared over 2, which is 2t squared. So I have equation for each of them to tell me the position versus the time. And when they meet, they will have same position, so I compare them. So I'll do 560 minus 12t equal to 2t squared. In my calculator, I can solve this quadric. Whatever. 5,3 is 2. 12 minus 560. T equals to 14. And the other t is negative. So I don't care for it. So it's 14 seconds. And if I want the x, the position, I'll just place 14, for example, here. So it's 2 multiplied by 14 squared is 329. If I want to check myself, I can do 560 minus 12 multiplied by 14, which is exactly the same, so my answer is good. I want to know the final, so let's just write them first. 329, t equals 14. Let's find the final velocity for it with this Vt plus At, so Vt will be equal for A vehicle. V0 is 0, A is 4, T is 14, which is 56. Now let's see the graph. V versus time. Time were 0 and 14. A started with velocity 0, it finishes with the velocity 56. So this is the equation for it. This is A. B with constant velocity minus 12. this is B. Let's see if it adds up. If I do the slope, vertical over horizontal, 56 divided by 14, it's 4, and the acceleration is 4, positive. If I calculate the area will be triangle. 14 multiplied by 56 divided by 2, 329. If I calculate this area, I'll get 14 multiplied by 12, rectangle, 168. Let's see if it adds up. This vehicle went this direction, 329. This vehicle went this direction, 168. When I add them up, 329. 560, so it adds up. If I want the x over t, A started with 0, finished 329, so it will be this graph. Again, why? Because it started flat. Slopes are the velocity. Velocity 0, 1, 2, 3, 4, 5, and the velocity will be 56. Again, if you want to see it in the higher math, this equation, this is the equation for this graph. If you derive it, you will get 14, which is exactly, we didn't do it, which is exactly the velocity. If I place 14, you'll get 4 multiplied by 14, it's 56. 56 is exactly the slope here. If I want the slope in another place, I can use another t. But usually you will not be asked for that. Okay, the other graph is, what was the velocity, the x? It started with 560, 560, and it finished here, but it's a straight line. Why straight line? Because the velocity is constant, the slope is constant, and it's minus because it's against our positive direction. If I do the slope, vertical over horizontal, let's do it. Vertical is 560 minus 392. This is 168 divided by 14. If I divide it by 14, I get exactly the 12, minus 12. So the slope is minus 12 and it's constant. So it adds up also. Very, very good and nice.